In this video, we will cover precision at K and recall at K, two metrics used to measure the effectiveness of a recommender system. We'll cover how to compute these metrics and then work through a simple example in Python. Hi, my name is Michael, and I run a blog called Inside Learning Machines, where I cover topics in data science and machine learning. My aim in this blog is to dive deep into machine learning algorithms and explain how they actually work. You can find a link to my blog in the description below. Now, with all that being said, let's jump into the topic. Okay, so as already mentioned, precision at K and recall at K are both metrics used to evaluate a recommender system. So let's take a closer look at what we mean by a recommender system. So recommenders are algorithms that attempt to suggest novel items to an end user. And by novel items, I mean items that this user has not used or seen yet. This can come in terms of, say, movie recommendations. It can come in terms of recommendations for different places to travel, for new and different products, etc., etc. So these algorithms typically base their recommendations on either the user's past behavior or user characteristic information. So now let's look at a small illustrative example to highlight these points. So here we see in this figure a very simplistic case where we have 4 different users. Each row outlines a different user, so they're all labeled here: user 1, user 2, user 3, and user 4. And each user has watched 4 different movies, as indicated by the different images in the row. Each unique image represents a unique movie. Now, there are 2 different genres of movies in this figure, either dinosaurs or comedies. So there are 2 widely different genres here. Now, each user has rated each individual movie that they have watched, and that rating is given below the image. And so a rating of 5 is the best possible rating, whereas a rating of 1 is the worst. So if we look at, say, user 1, for instance, this person has watched 3 different dinosaur movies and has rated them quite well. We have 4.5, 4.5, and 4. This person has also watched 1 comedy movie and given it a slightly lower rating of 3.5. If we go on to user 2, this person has also watched 3 different dinosaur movies. The first 2 are rated quite highly, whereas the last dinosaur movie has a somewhat lower rating. This person has also watched 1 comedy movie and given it a reasonable rating of 3. Now, user 3 has watched 3 different comedy movies, and where the first 2 are given a quite high rating of 5. And this person has also watched 1 dinosaur movie with also a reasonably high rating of 4. The final user has watched only comedy movies, and the ratings that this person has given are kind of a mixed bag, with a very high rating at the beginning and progressively lower ratings as we move along the row. So if we have the task of trying to recommend movies to any of these users, the strategy we can follow is by grouping together like users and then basing the recommendations on movies that were rated highly by other users in the group but have not been yet watched by the user we're interested in. So if we're interested, for example, if we're interested in recommending movies to user 1, we first need to group together the most similar users to user 1. And based on these images, that user would be user 2. And this is because both user 1 and user 2 have watched a lot of dinosaur movies and rated them quite well. So if we want to make a movie recommendation to user 1, we look at user 2 and see what is the most highly rated dinosaur movie that user 2 has watched that user 1 has not watched. And that would happen to be the first movie here that user 2 has watched and given a rating of 5. And so this would be a reasonable rating or a reasonable recommendation to give to user 1. And this, although this is a very simplistic example, this is in essence how recommenders function. Now, this example only makes use of the past behavior of these different users. We can also enrich these recommendations based on characteristic information, such as the user's age, their geographic location, or the languages that they like to watch movies in. All of that can be used to enhance the recommendations that we can provide. Now let's just define a few terms. The recommended items are items that are suggested by our model to a user. Relevant items are items that were actually selected by a user. So if we want to think of this in terms of more conventional terminology in machine learning, the recommended items are the predictions that our model generates, and relevant items are the true values. Those are the values that users actually find useful. And we'll use these terms to define our metrics. So when we define precision at k and recall at k, we're going to do it in terms of recommended and relevant items. In addition to, we will only look at the top k suggestions from our algorithm, where k is an integer value. So that could be 5, 10, whatever integer we want. And the reason why we pick this integer value, this limit, is because in general, a recommender can give an arbitrary number of recommendations to a user. Now that's of course based on or limited by the data that we use to train the recommender. But in essence, a recommender can give far more recommendations to a user than a user can realistically consume. If we go back to the movie recommendation example, for instance, a recommender could give, say, 100 recommendations a week to a user, whereas a user can only realistically watch 10, for instance. So in that case, it may make more sense to evaluate our models where k is equal to 10. Now here is how we actually evaluate precision at k and recall at k. So precision at k is given by the number of recommended items that are relevant at k divided by the number of recommended items at k. And so this just measures the percentage of recommended items produced by our model that actually end up being relevant to the end user. Recall at k is given by the number of recommended items that are relevant at k divided by the number of all relevant items. And so this measures the number or the amount of relevant items that we are capturing with our model. Okay, so now we can jump into a Jupyter Notebook and work through an implementation of precision at k and recall at k. To do this, I'm going to create a very simple dummy data set in pandas, in a pandas data frame. And so that's in this cell right here. I've just generated a data frame with 2 columns, y actual and y recommended. Each column represents ratings that a user has given to a particular item. Y actual is the true ratings that a user has given, whereas y recommended are the predicted ratings that were generated by a model. Now keep in mind that this is just very simple data set that I just generated by hand. So the first things we're going to need to do now is to format our data. And the way we're going to do that is first we're going to sort our data frame by the recommended column in descending order. And then I'm going to drop the rows with missing values in it. Next, we need to convert these ratings into a binary quantity. And so that mimics the relevant and non-relevant terms that I mentioned previously. So the way I'm going to do this is I'm going to define a threshold, and that's here, a threshold of 2, where any rating that is greater than or equal to this threshold is going to be given a value of true. That implies that the item is relevant. Likewise, for items that fall below this threshold, they are given a value of false, and so they will be interpreted as non-relevant. So let's run this and see what we get. So now if we take a look, we see that our formatted data frame, now it still has the 2 columns like before, but now these contain Boolean values. So now let's just run through an implementation of the metrics, precision at k and recall at k. First, I'm going to define a decorator, and this just checks that the inputs to our metric functions make sense. And next, I'm going to define precision at k. And so precision at k takes in as arguments the data frame that I just mentioned, along with a k value, and then 2 strings that represent the column headings for ytest and yprediction. This is analogous to, ytest is analogous to the actual ratings, and yprediction is analogous to the recommended column. And so now, inside this function, I first extract out the top k rows. I then compute the denominator, I compute the numerator, and then I return the ratio if the denominator is greater than 0. Otherwise, I return none. Likewise, for recall at k, I pretty much proceed in the same fashion. So I first extract out the top k rows from the data frame, I compute the numerator, I compute the denominator, and then I return the ratio, so long as the denominator is greater than 0. So these are the definitions. We can run this cell. And now let's see what kind of results we get for different values of k. So now the first case I'm going to look at is where k is very small. It's only equal to 3. Let's see what we get. So here we see we have a precision at k value of 0.67 and a recall at k of 0.17. And what this tells us is that the 3 recommended items to our user are generally rated quite well. They are actually relevant to that user. That's what the precision at k, the high score for the precision at k tells us. However, the recall at k is quite low. And what this implies is that we are missing quite a lot of the relevant items that exist in our data set. Now this can be explained by the fact that our k value is quite low. So now let's try again, and let's increase the k value to 10. And now we see we have a precision at k of 0.4 and a recall at k of 0.33. So the lower value for our precision at k tells us that now a lot more of the recommended items actually turned out to be not so relevant. So only 40% of the recommended items are actually relevant to the end user. However, the recall at k has gone up to 0.33, and this says that we have captured a lot more of the true relevant items to that user. And that makes sense It's because that we've increased our sample size of k, and we would expect that the recall would go up with that. So now let's take it a little bit further and go with k equals 15. And now here we see that the precision at k has gone up again to 0.54, and the recall at k has gone up again to 0.58. And what this tells us is that with the precision at k, now just over half of all the recommended items are actually relevant to our end user, whereas with the recall at k, we can see that now we're capturing even more of the total number of relevant items to that user. And that again is expected with the increased value of k. So I hope that this simple example provides a nice illustration for how to implement precision at k and recall at k, and how to interpret the results. If you enjoyed this content, please like the video or subscribe to the channel. If you would like to learn more about precision at k and recall at k, or machine learning in general, please visit my site, insidelearningmachines.com. I have included a link to my article on precision at k and recall at k in the description below. Have a great day, and see you in the next video.